So welcome to today's lecture, and in this lecture we're going to talk about parametric and non-parametric testing. Now you can only do parametric or non-parametric testing when you have a continuous variable. And you can only do parametric testing if three assumptions are met: that you have normalcy of your data or normal distribution, there's independence in your data, so one group does not influence the other, and you have homogeneity, so that the variances within each group are similar. If you have these three, you're able to do parametric testing. Now, what are those tests? Parametric testing is the type of test that most of you are familiar with. The mean or the average is a type of parametric test. The standard deviation is a type of parametric test. You can do t-tests, and you can do what's called ANOVA, analysis of variance. So the mean or the average is a simple calculation. The standard deviation tells you how far each value in your set of data is from the mean. Smaller standard deviations mean or indicate, that the data you have is very close to the average. Larger standard deviations mean that the data you have is far away from the average and that the average may not accurately reflect all of the data points. T-tests come in two types, or two general types: a pool type and a Satterthwaite type. You don't need to really know both of those as an introduction to biostatistics, but you should know that t-tests are done on continuous variables that display normalcy, independence, and homogeneity. And ANOVA is just an acronym for analysis of variance across groups. So if you have more than two groups that you're comparing, 3, 4, or more, you can use an ANOVA test to determine if there's any difference between any of the groups. An ANOVA test won't tell you which group is different from another group, but it will tell you that amongst all your groups, one of these groups at least has a different result than all the others. T-tests are commonly used when you have two sets of data or two groups, and ANOVA testing is done when you have more than two groups. Say you don't have parametric testing available because you don't meet normalcy, independence, or homogeneity. Then you have to use non-parametric testing, and the common tests there include the median, the range, interquartile ranges. What you're doing with non-parametric testing is you're testing something called the ranks. And you may read that or hear about it as you come along. And the data is ranked according to median or range or their interquartile range or even the mode. So non-parametric testing gives you a little bit less flexibility in the type of tests you can do compared to parametric testing. Now there are some statistical tests that you can do, and I haven't listed them here. These are the very simple statistical tests that you can do, but there are others that you can do. So it's not that non-parametric testing is less valid or less robust. It's just used for data that doesn't meet any one of these three. You do have one other option, and we're going to show that on the next slide. You could take your your non-parametric data and just convert it to parametric data. If you did that, there's a theorem called the central limit theorem, which says you could then use all of the statistical tools for parametric data with this non-parametric data that you converted. So you'd be able to use the mean, the standard deviation, a t-test, or an ANOVA test. Now you've seen these conversions before. You can do that most commonly by putting the data on a log scale. So you may have wondered when reading scientific papers, why do they measure the data outright but then plot the data on a log scale? Because what they're trying to do is achieve either a normal distribution or homogeneity, not really independence so much, so put that in parentheses, but they're trying to achieve either normalcy or heterogeneity using a log scale. And if they can achieve that, then the central limit theorem says they can use parametric testing. They could have just as easily taken their non-parametric data and used non-parametric testing, but the researchers have to decide which method is a better statistical method to use. So that's basically parametric and non-parametric testing. You could take parametric data and do all sorts of manipulations with it using statistics. You can take non-parametric data and also use statistics to get a clear idea of what your data says and get a better interpretation. Or you can take your non-parametric data and try to make it parametric so that you can use some of those previous tests we discussed. And that's it. Thank you very much.